ਸਿਆਲਾਂ ਦੀ ਸ਼ਾਮ ਨੂੰ ਕੱਚ ਦੇ ਕਿਸੇ ਗਿਲਾਸ ਵਿੱਚ ਉਬਲਦੀ ਹੋਈ ਚਾਹ ਪਾਉਣ ਨਾਲ ਗਿਲਾਸ ਦਾ ਤੜਕ ਕਰਕੇ ਟੁੱਟ ਜਾਣਾ ਤੁਹਾਡੇ ਵਾਸਤੇ ਕੋਈ ਨਵੀਂ ਗੱਲ ਨਹੀਂ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਕੰਕਰੀਟ ਰੋਡਸ ਅਤੇ ਸਾਈਡਵਾਕਸ ਵਿੱਚ ਕ੍ਰੈਕਸ ਦਾ ਹੋਣਾ ਵੀ ਆਮ ਹੀ ਹੈ। ਕੀ ਤੁਹਾਨੂੰ ਪਤਾ ਹੈ ਕਿ ਰੇਲਵੇ ਟਰੈਕਸ ਤੇ ਗਾਰਡਰਾਂ ਦੀਆਂ ਸਲੈਬਾਂ ਅਤੇ ਬ੍ਰਿਜਸ ਵਿਚਕਾਰ ਸਪੇਸਿਸ ਕਿਉਂ ਛੱਡੀਆਂ ਜਾਂਦੀਆਂ ਹਨ? ਕਿਉਂ ਟੈਲੀਫੋਨ ਲਾਈਨਸ ਅਤੇ ਇਲੈਕਟ੍ਰੀਕਲ ਲਾਈਨਸ ਨੂੰ ਇਹਨਾਂ ਦੇ ਖੰਭਿਆਂ ਵਿਚਕਾਰ ਜ਼ਿਆਦਾ ਟਾਈਟ ਕਰਕੇ ਨਹੀਂ ਬੰਨਿਆ ਜਾਂਦਾ? ਸਟੀਲ ਬ੍ਰਿਜਸ ਦਾ ਇੱਕ ਐਂਡ ਕੰਕਰੀਟ ਵਿੱਚ ਫਿਕਸ ਨਹੀਂ ਕੀਤਾ ਜਾਂਦਾ? ਜਾਂ ਰਸੋਈ ਵਿੱਚ ਵਰਤੇ ਜਾਣ ਵਾਲੇ ਕੱਚ ਦੇ ਭਾਂਡੇ ਪਤਲੇ ਕੱਚ ਨਾਲ ਕਿਉਂ ਨਹੀਂ ਬਣਾਏ ਜਾਂਦੇ? ਅੱਜ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਅਸੀਂ ਇਹਨਾਂ ਨੈਚੁਰਲ ਅਤੇ ਹਿਊਮਨ ਕੰਟਰੋਲਡ ਫੈਨੋਮੇਨਾ ਦੇ ਕਾਰਨ ਜਾਣਾਂਗੇ। ਦਰਅਸਲ ਇਹ ਸਾਰੀਆਂ ਐਕਟੀਵਿਟੀਜ਼ ਥਰਮਲ ਐਕਸਪੈਂਸ਼ਨ ਦੀ ਵਜ੍ਹਾ ਕਰਕੇ ਹੁੰਦੀਆਂ ਹਨ। ਆਓ ਇਸ ਨੂੰ ਸਮਝਣ ਲਈ ਇੱਕ ਤਰਤੀਬਵਾਰ ਸਟੱਡੀ ਸ਼ੁਰੂ ਕਰੀਏ। Let us drop a piece of red hot iron into cold water. The water would become hot and the red hot iron piece will cool down till the temperatures of the two become equal. It indicates that something has flown from red hot iron piece to water. This something which flows from a body at higher temperature to another body at lower temperature when the two are in contact is called heat. Earlier, it was believed that heat is a type of fluid called caloric. Every body was supposed to have a certain amount of caloric in it. When some caloric was added to the body, its temperature raised, and when some caloric escaped out from the body, its temperature fell down. Caloric was considered as invisible, weightless, and odorless fluid. However, caloric theory could explain some of the observed effects of heat. For example, rise or fall in temperature of a body, expansion or contraction of a body, change in state of a body from solid to liquid and from liquid to gas, and so on. But caloric theory failed to explain the production of heat due to friction. For example, when we rub our hands against each other, we feel warm. In a similar way, when two pieces of metal are rubbed together, heat is produced. These observations led to the dynamic theory of heat, according to which heat is a form of energy called thermal energy. According to the dynamic theory of heat, every body is made up of a large number of tiny particles called molecules. Depending on the nature of the substance, that is, solid, liquid, or gas, and the temperature of that substance, the molecules may possess translatory motion, vibratory motion, and rotatory motion. हर एक टाइप ਦਾ motion molecules ਨੂੰ ਕੁਝ kinetic energy provide ਕਰਦਾ ਹੈ। ਕਿਸੇ body ਦੁਆਰਾ possessed heat ਇਸ ਦੀ total thermal energy ਦੇ ਬਰਾਬਰ ਹੁੰਦੀ ਹੈ, ਜੋ ਕਿ body ਦੇ ਸਾਰੇ individual molecules ਦੀ translational, vibrational ਅਤੇ rotational motion ਕਾਰਨ kinetic energies ਦੇ sum ਦੇ ਬਰਾਬਰ ਹੁੰਦੀ ਹੈ। In fact, the energy associated with configuration and random motion of the atoms or molecules of the body is called internal energy of the body. Heat energy is a part of internal energy which is transferred from one body to the other on account of temperature difference between the two bodies. Thus, heat energy is the internal energy of a body in transit, while temperature is the degree of hotness of a liquid or of a solid or of a gas. In general, heat is a cause and temperature is its effect. In the SI system, unit of heat is joule. and that of temperature is degree Celsius or Kelvin. Temperature and thermal energy vary directly, but they are not the same thing. In general, temperature is not energy. It is a measure of the average heat or thermal energy of the particles in a substance. And heat is energy. Temperature measure ਕਰਨ ਲਈ thermometer ਦਾ ਉਪਯੋਗ ਕੀਤਾ ਜਾਂਦਾ ਹੈ। Temperature ਨਾਲ materials ਦੀਆਂ physical properties sufficiently change ਹੁੰਦੀਆਂ ਹਨ। ਇਸ ਕਰਕੇ thermometer construct ਕਰਨ ਤੋਂ ਪਹਿਲਾਂ ਇਹੋ ਜਿਹੀਆਂ properties ਧਿਆਨ ਵਿੱਚ ਰੱਖਣੀਆਂ ਚਾਹੀਦੀਆਂ ਹਨ। ਸਭ ਤੋਂ commonly used property ਹੈ variation of the volume of a liquid with temperature. For example, most common thermometer यानी liquid in glass type thermometer ਹੁੰਦਾ ਹੈ। ਅਜਿਹੇ thermometers ਵਿੱਚ mercury ਅਤੇ alcohol ਇਹ ਦੋ liquids ਆਮ ਤੌਰ ਤੇ ਵਰਤੇ ਜਾਂਦੇ ਹਨ। Thermometers are calibrated so that a numerical value may be assigned to a given temperature. For the calibration of any standard scale, we need two fixed reference points. The ice point and the steam point of water are two fixed points and are known as the freezing and the boiling points. These 2 points are the temperatures at which pure water freezes and boils under standard pressure. To measure the temperature, we use different measuring scales such as Fahrenheit scale, Celsius scale and Kelvin scale. The ice and steam points have values 32 degree Fahrenheit and 212 degree Fahrenheit respectively on the Fahrenheit scale, and 0 degree Celsius and 100 degree Celsius on the Celsius scale. On the Fahrenheit scale, there are 180 equal intervals between two reference points, and on the Celsius scale, there are 100. Liquid and glass thermometers show different readings for temperatures other than the fixed points because of differing expansion properties. However, a gas thermometer gives the same readings regardless of which gas is being used. ਪਹਿਲਾਂ constant volume gas thermometer use ਕੀਤਾ ਜਾਂਦਾ ਸੀ। Gas thermometer ਵਿੱਚ gas ਦਾ volume constant ਰੱਖਿਆ ਜਾਂਦਾ ਹੈ ਤਾਂ ਕਿ pressure proportional to temperature ਮਿਲ ਸਕੇ। So, constant volume gas thermometer ਨਾਲ temperature pressure ਦੀ terms ਵਿੱਚ read ਕੀਤਾ ਜਾਂਦਾ ਹੈ। ਜੇ pressure ਅਤੇ temperature ਵਿਚਕਾਰ graph plot ਕੀਤਾ ਜਾਵੇ ਤਾਂ ਇੱਕ straight line ਮਿਲਦੀ ਹੈ। ਹਾਂ, real gases ਲਈ measurements ਇੱਕ large temperature range ਲਈ linear plot show ਕਰਦੇ ਹਨ ਅਤੇ ਇੱਕ ਖਾਸ temperature ਤੇ pressure 0 ਹੋ ਜਾਂਦਾ ਹੈ। ਜਿਸ temperature ਤੇ pressure 0 ਹੋ ਜਾਂਦਾ ਹੈ ਉਹ -273.15 डिग्री सेल्सियस पाया गया है ਅਤੇ ਇਸ ਨੂੰ absolute zero ਵੀ ਕਿਹਾ ਜਾਂਦਾ ਹੈ। absolute zero ਹੀ Kelvin temperature scale ਦੀ foundation ਹੈ। ਇਸ scale ਤੇ -273.15 डिग्री सेल्सियस ਨੂੰ scale ਦਾ 0 point यानी 0 Kelvin ਮੰਨਿਆ ਗਿਆ ਹੈ। The relationships between the different temperature scales are value in Kelvin is equal to 273.15 plus the value in degree Celsius, whereas the value in degree Fahrenheit is equal to 9/5 times the value in degree Celsius plus 32 degree. When we increase the temperature, it results in an increase in the kinetic energy of the molecules or atoms of the substance and an increase in thermal energy. It is our common experience that most substances expand on heating and contract on cooling. A change in temperature of a body causes change in its dimensions. increase in the dimensions of a body due to the increase in its temperature is called thermal expansion. You must know why do the dimensions of an object change with change in temperature. Solids ਅਤੇ liquids ਦੇ molecules ਸਦਾ ਹੀ ਵਾਈਬ੍ਰੇਟ ਕਰਦੇ ਰਹਿੰਦੇ ਹਨ। ਜੇ ਟੈਂਪਰੇਚਰ ਫਾਲ ਹੁੰਦਾ ਹੈ ਤਾਂ molecules ਘੱਟ ਵਾਈਬ੍ਰੇਟ ਕਰਦੇ ਹਨ, ਇੱਕ ਦੂਜੇ ਦੇ ਨੇੜੇ ਆ ਜਾਂਦੇ ਹਨ ਅਤੇ ਸਬਸਟੈਂਸ ਕੰਟਰੈਕਟ ਹੋ ਜਾਂਦਾ ਹੈ। ਇਸੇ ਤਰ੍ਹਾਂ ਜੇ ਟੈਂਪਰੇਚਰ ਰਾਈਜ਼ ਹੁੰਦਾ ਹੈ ਤਾਂ molecules ਜ਼ਿਆਦਾ ਵਾਈਬ੍ਰੇਟ ਕਰਦੇ ਹਨ, ਇੱਕ ਦੂਜੇ ਤੋਂ ਦੂਰ ਚਲੇ ਜਾਂਦੇ ਹਨ ਅਤੇ substance expand ਹੋ ਜਾਂਦਾ ਹੈ। If you try to stop something from expanding, then it may cause a very large force. Sometimes these forces create serious problems, but at other times they may be useful. For example, in Saudi Arabia, the temperature at midday in July can rise to as high as 50 degrees Celsius. But in January, the temperature can drop below 0 degrees Celsius. These large temperature changes cause problems with oil pipelines. A long, straight length of pipe would easily crumple under the forces caused by expansion. However, this can be avoided by putting a series of expansion loops into the line. These loops make the line more flexible so that it is free to expand or contract as the temperature changes. Let us see some activities.
To open a tightly closed metallic lid of a bottle, we may have to put the bottle in some hot water. In that way, metallic lid expands a little, gets loose, and can easily be opened. Here you are observing a metallic sphere, which can pass through the given ring easily. When we heat the sphere, its size increases, and the sphere could not be passed through the ring. Let us see an interesting activity. Here, we are showing you balloon over an empty bottle, and it does not show any expansion when kept at room temperature. Now, we place the bottle along with balloon in hot water. Due to increase in temperature, air molecules in bottle expand, and because of this, the balloon also gets inflated.
It is a matter of common experience that most forms of matter, that is, solids, liquids, and gases, expand to different degrees on heating and contract when cooled. Let us describe the thermal expansion in the light of atomic theory. Let us see the potential energy curve of interatomic or intermolecular potential. When temperature is very low, of the order of 0 Kelvin, the molecules remain at separation R0. Let the temperature of the substance be increased to T1. As the molecules acquire energy, they can come to a minimum distance R minimum, and on being repelled, they can go to a maximum distance R maximum corresponding to points A1 and B1 respectively. Due to asymmetrical shape of potential energy curve, the distance R0 minus R minimum is less than R maximum minus R0. Therefore, mean of separation between molecules becomes R1 equal to R minimum plus R maximum by 2, which corresponds to point P1, and it is found that R1 is greater than R0. If the temperature is further increased to T2, then the mean separation between the molecules becomes R2 corresponding to point P2. Now, R2 is greater than R1. It implies that separation between molecules increases with increase in temperature. It explains the fact that the substances expand on heating. It can be noticed that all materials do not expand by the same amount when heated. Expansion process due to heating has three types: A. Linear expansion, B. Superficial or area expansion, and C. Cubical or volume expansion. Let us see what is linear expansion.
Linear expansion. You are observing a metallic rod. If we can observe its molecular motion, you will find that the molecules of the material are vibrating slowly. When we heat up the rod, the molecules start vibrating more rapidly, which causes some expansion in the rod. Here you can see the difference in the length of rod before and after heating. This is called as linear expansion.
So, ये कहा जा सकता है that on heating, if there is only increase in length, then it is called as linear expansion. Linear expansion सिर्फ solids which ही possible होता है. For any type of material, it is possible to measure up to what extent that material will expand or contract whenever there is a change in temperature. In general, this degree of expansion is known as the coefficient of expansion. In general, a coefficient is a number that measures some characteristic or property of that material. The coefficient of linear expansion is a constant that governs the degree to which the length of a solid will change due to a variation in temperature. Do you know how can we measure the coefficient of linear expansion? Let us take a wire of some metal and we consider at room temperature initial length of the wire is L. If the wire is heated in such a manner that it expands lengthwise only. For small change in temperature delta T, let the change in length be delta L. This change in length depends upon the change in temperature delta T and its original length L. We can write it as delta L equal to alpha L into delta T, where alpha is the constant of proportionality known as coefficient of linear expansion. It is constant for a particular material. Using this relation, we can measure the coefficient of linear expansion as alpha is equal to fractional change in length divided by change in temperature, that is delta L upon L into 1 by delta T. Let us see what is superficial expansion.
You are observing a metallic plate. If you observe its molecular motion, you will find that the molecules of the material are vibrating slowly. When we heat up the rod, the molecules start vibrating more rapidly, which causes some expansion in the plate. Here you can see that difference in the area of the plate before and after heating. This is called as superficial expansion.
So, on heating, if there is increase in surface area only, it is called as superficial expansion. Superficial expansion भी सिर्फ solids which ही possible है. Let us take a thin plate of some metal and we consider at room temperature initial surface area of the plate is S. If the plate is heated in such a manner that it expands area-wise only. For small change in temperature delta T, let the change in surface area be delta S. This change in area depends upon the change in temperature delta T and its original area S. We can write it as delta S equal to beta S into delta T, where beta is the constant of proportionality known as coefficient of superficial expansion. Hence, beta is equal to fractional change in surface area divided by change in temperature, that is delta S upon S into 1 by delta T. Coefficient of superficial expansion is a constant that governs the degree to which the surface area of a solid will change due to a variation in temperature. Obviously, linear ਅਤੇ superficial expansions सिर्फ solids ਤੇ ਹੀ apply ਕੀਤੇ ਜਾ ਸਕਦੇ ਹਨ. But a liquid and a gas occupies the shape of their container. Hence, their length remains same as that of the solid that contains it. Therefore, liquids and gases, when heated, show volume expansion. That is, a change in volume as a result of a change in temperature. Similarly, when we heat some solid material of any shape, say in the form of a cube, there would be an increase in its length, breadth and thickness. Thus, there will be some increase in the volume of that solid cube. Similar to linear and superficial expansion, on heating, if there is increase in volume, it is called as cubical expansion. Volume expansion is possible in solids, liquids and gases. Let us see another activity.
Here you are observing a metallic block. Observe its molecular motion. You will find that they are vibrating slowly. When we heat up the block, the molecules start vibrating rapidly, which causes some expansion in the block. Here you can see that difference in the size of block before and after heating. It is clearly observable that the volume of the block has increased. Let us see what happens in case of liquid. Take some liquid in a conical flask. For more clear observation, we close the flask with a cork and insert a glass tube so that we can observe any expansion in liquid through the variation in liquid height in the glass tube. When we place the flask over a sprit lamp for heating, you can clearly see that the length of liquid column in the glass tube increases on heating. All these expansions are called cubical expansion.
Let us take a cube of some metal at room temperature T, having initial volume as V. The cube is heated in such a manner that it expands volume-wise. For small change in temperature delta T, let the change in volume be delta V. This change in volume depends upon the change in temperature delta T and its original volume V. We can write it as delta V equal to gamma V into delta T, where gamma is the constant of proportionality known as coefficient of cubical expansion. Hence, gamma is equal to fractional change in volume divided by change in temperature, that is delta V upon V into 1 by delta T. Coefficient of volume expansion is a constant that governs the degree to which the volume of a solid or liquid or gas will change due to a variation in temperature. It is clear that SI unit for the coefficient of expansion is per degree Celsius. There is a close relation between alpha, beta and gamma. Consider a solid cube of each side L. Volume of the cube V is equal to L cube. Let this cube be heated by a small change in temperature delta T. Let us consider delta L as a small increase in length of each side and delta V as corresponding small change in volume of the solid cube. We know that the increase in length delta L is equal to alpha into L into delta T and increase in volume delta V is equal to gamma into V into delta T, whereas increased length L plus delta L is equal to L into 1 plus alpha into delta T and increased volume V plus delta V is equal to V into 1 plus gamma into delta T. New volume of the solid cube V plus delta V should be equal to the cube of L plus delta L. On substituting the values for delta V and delta L, we get V into 1 plus gamma into delta T equal to L cube into cube of 1 plus alpha into delta T. Since V is equal to L cube, therefore 1 plus gamma into delta T is equal to 1 plus 3 alpha delta T plus 3 alpha square delta T square plus alpha cube delta T cube. Since the values of alpha and gamma are very small, hence neglecting the higher powers of alpha and gamma, we get gamma delta T equal to thrice alpha into delta T. That is, gamma is equal to thrice alpha. Similarly, it can be proved that beta is equal to twice alpha. In other words, alpha is equal to beta by 2, which is also equal to gamma by 3. Let us see some more applications of thermal expansion.
The traditional way to fasten an iron rim to a wooden wheel was to heat the rim red hot. Initially, the size of the rim was kept same as the size of wheel. This means it was impossible to fix the rim of the wheel. Heating of the iron rim made it slightly larger, so that the wheel could be forced into the rim. After the rim cooled and shrank, it was firmly held in place. Another example of thermal expansion in a solid is the sagging of electrical power lines on a hot day. This happens because heat causes them to expand, and thus there is a greater length of power line extending from pole to pole than under lower temperature conditions. Cement floors and sidewalks are built in sections with glass plates between the sections. Otherwise, they would crack on very cold days and heave and crumple on very hot days. Most railway tracks are built from pieces of steel supported by wooden ties and laid with a gap between the ends. This gap provides a buffer for thermal expansion. Can you imagine what would happen if there is no gap? Steel has a relatively high coefficient of thermal expansion. Railroad tracks are constructed so that they can safely expand on a hot day without derailing the trains traveling over them.
Before the end, there is a quick question-answer session for you. My first question goes like this. Define thermal expansion. And the definition is, on heating, if there is only an increase in dimension, then it is called as thermal expansion. The next question is, why one end of a steel bridge is not fixed in concrete? The answer is, if steel bridge expands or contracts, it can cause structural damage. ਮੈਨੂੰ ਪੂਰਾ ਭਰੋਸਾ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਇਹ ਟੌਪਿਕ ਇੰਟਰਸਟਿੰਗ ਵੀ ਲੱਗਿਆ ਹੋਵੇਗਾ ਅਤੇ ਯੂਸਫੁਲ ਵੀ। ਤੁਹਾਡੀ ਅਟੈਂਸ਼ਨ ਲਈ ਸਾਰਿਆਂ ਦਾ ਧੰਨਵਾਦ। See you next time again with something new.